Okay. Good morning, students. So, in your after puja vacation, this is your first class, and we have done, I think, maximum of the chapters. Few chapters are remained, which we are going to complete. So, today we are starting the chapter triangles. Okay. And before starting the chapter, there are few things that you need to understand. First, what is required is the difference between congruency and similarity. So in our lower classes, that means in your class 9, we have understood congruency. So what is congruency? Suppose these two triangles are there, ABC and DEF. Okay. Now these two triangles are said to be congruent. There are many criterias with there: angle side angle criteria, side angle side criteria, then we have side criteria, then we have RHS criteria. These are all we are familiar with, right? So in order to be congruent, these two triangles should be of on the same size, same shape and everything. Okay, in simple words, these two triangles are congruent means they are of same shape, same height, everything same. Okay, this is congruency. This is congruency. Now we are going to understand similarity. Now this is where it differs from congruency. Suppose this is a triangle, okay, and this is a triangle. Okay, so these two triangles are there. Now, are they congruent? Absolutely not. But they can be similar. That means two triangles of unequal size may be similar, but they may not be congruent. Let me repeat. Two triangles of different shape and size can be similar, but cannot be congruent. Here you can see this is a small triangle, there this is a big triangle, but these two triangles can be similar when when their the ratio between their corresponding sides are equal. That means there is a triangle ABC and there is a triangle DEF. Okay, now these two triangles, one small and one big, can be similar. How? If the ratio between the corresponding sides. Now what does it this term corresponding means? Corresponding means same side, on the same side. So there is a triangle and we will not compare it with a triangle like this. You can compare though, but it will be easier for you to understand if you just redraw the triangles like this. Okay, so the corresponding sides ratio should be same. That means suppose here we are writing the small one first. So AB by BC, suppose we are writing. So here we have to write DE by EF, not the other way around, right? We are writing here first AB in the numerator. So here also in the numerator we have to write DE. That means its corresponding sides. Okay. Here we have written BC, so there we have to write EF. We cannot write DF. Fine. And finally we have AC by DF. Clear? So these two triangles can be similar if the ratio of the corresponding sides are equal. This is similarity. I'm not going on to details here. Okay, I'm not going on to details. I'm just going slow but steady, and this is just the basics. Clear? I hope you have understood this one. Okay. Now, based on this one, that means this proportionality, right? Not the similarity. Similarity we will learn little bit later. But based on this proportionality, now we are going to learn some theorem. Some means here in this case two. We are going to understand two theorems. Okay. So I shall erase it. Okay. But before starting this theorem, let me recall something first. In our previous class, we have learned this midpoint theorem. Right? We have learned this. Now, what is the midpoint theorem? Because there is a similarity here in this case with the theorem that we are about to understand. So, midpoint theorem says if I draw a line through the midpoint, or if I join the midpoints of two sides by a line, then this line will be parallel to the third and equals to half of it. That means if it is DE, then we would have DE parallel BC, and DE is equal to half of BC. Okay. DE parallel BC and D equals half of BC. Clear? So this is what we have learned in our previous class. That means class 9. Now the theorem we are about to understood is very similar to this theorem, but we can call it that midpoint theorem is just a special case of the theorem that we are going to know right now. You can think that this theorem is just a special case of the midpoint theorem. Okay. Fine. So let us read the statement then. The statement says, this is theorem 6.1. right, in your NCERT book. If a line is drawn parallel to one side, if a line is drawn parallel to, or I'm writing in words, parallel to one side of a triangle to intersect the other of a triangle to intersect the other, two sides in distinct points, other two sides in distinct points, the other two sides are divided in the same ratio. The other two sides are divided in the same ratio, right? So this is just like the converse of the midpoint theorem, right? In a midpoint theorem, what do you have? The converse part, that if I draw a parallel line, right, then it will bisect the other side. Like in our converse midpoint theorem, what we have? If I draw a parallel line, right, from any point D, then this line should bisect this side. That was the converse midpoint theorem, right? So this is a kind of similar to this. Okay, so here it says if a line is drawn parallel to one side, so let us draw a triangle. Suppose we have drawn a triangle. Suppose I'm doing it slightly like this. Okay, right? And suppose any, now this is where it differs from midpoint theorem. In midpoint theorem we have a line drawn through the midpoint. Here any point, if you are drawing a line parallel to this one in any point, suppose here D is not necessarily the midpoint, right? Any point on this line, we are drawing DE parallel BC, then the question says that this should divide this triangle in equal ratio, right? So what we have to write? Let ABC be a triangle in which DE parallel BC, right? So a line is drawn parallel to one side, right? That part is done. To intersect the other, right? Then two sides in distinct points, the other two sides are divided in the same ratio. So what we need to prove, right? We need to prove that, what we need to prove? We need to prove AD by DB is equal to AE by EC. As I have said, AD by DB is equal to AE by EC. Clear? That we need to prove. So now construction, right? So what we need to construct is, suppose we are drawing two perpendicular from the line D. Suppose this is DM, and now here we are drawing parallel to this DN. Okay, clear? These are perpendiculars. We are drawing two perpendiculars. So in the construction, what do we write? Let us draw DM perpendicular AC and EN perpendicular. Instead of AC, write AE because we will need AE. So AC means AE, same line. So instead of AC, we are writing AE, and instead of AB, we are writing AD. Clear? Okay. Now, okay. So suppose we are this and this. Now, why we are joining BE and DC? Because those we will require. Okay. Fine. And we write we join BE and DC. Clear? Why? You will know soon enough. Now proof. The first, we have to take how to approach this proof. We have to take two triangles in which this line AD should be there and DB should be there. Now you can see this AD and DB. In which triangle we have AD and DB? AD and DB. Now AD side should be in triangle ADE. See, right? Triangle AD. And in triangle BDE, we have BD. Understood? So how to approach this sum? We have to prove AD by DB. So now you see AD in which triangle? Now AD is in triangle ADE. So we are doing it at once. So area of triangle ADE by area of triangle DBE. That is how we understood which two triangles should we take. So ADE area will be what? Half into base. Base means what? Here AD into height. Height means this perpendicular that we have drawn, right? So any by area of triangle BDE, again BDE will be half into BD into, now see this triangle also EN is the height. Yes or no? Height means what? Height means the distance, the perpendicular distance from vertex to the base. Now since this triangle is like this, so the perpendicular distance should be any for triangle BDE also. Okay, so you write NE. Now this any cuts down, half up cuts down, so what we have? AD by DB. This you put as equation 1. Okay. Now so AD by DB, sorry, AD and DB we have. Now we need what? We need AE and EC, right? Now AE belongs to which triangle? You can see AE belongs to triangle ADE, so we need to take ADE, and EC belongs to triangle DEC, so we need to take DEC, right? So similarly we are now doing, therefore area of triangle ADE by area of triangle DEC. Clear? What we have? Area of AD will be what? Half into base into height. So AE into DM, right? So half into AE into DM. Clear? Again, DEC will be what? Half into EC into DM. Yes or no? So half into EC into DM. Half cut down, right? DM cut down. So what we have? AE by EC. This is 2. Now what we will do is we will divide 1 by 2. So what we are doing is we are dividing 1 divided by 2. So 1 divided by 2 means what? Right hand side we also divide, left hand side we also divide. So since we are dividing 1, so I am writing the left hand side at first. So area of triangle ADE by area of triangle DBE, right? Now when I am dividing this portion by this portion, what we have? Multiply its reciprocal, right? This 2 by 4 divided by 3 by 6, what do we have? 2 by 4 into 6 by 3. Understood? So whatever is in the denominator, if it is in fraction form, it will be multiplied followed by their reciprocal, or the reciprocal of the denominator. So here we also will do the same thing. So here this will be reversed. So multiply area of triangle DEC by area of triangle ADE. Clear? And in the right hand side also, at first we need to write this. So AD by DB. Now here we are writing like this: AD by DB whole divided by AE by EC. There is a reason to write this, right? Now you understand this one. This is very important. Triangle AD cut down. Both are triangle area of triangle AD cut down. So what we have in the left hand side? Area of triangle DEC by area of triangle DBE. Okay, is equal to, we have whatever we have here, AD by DB unchanged, whatever we have, AE by EC. Now understand this one. Let us see these two triangles, DEC and ABE. See, DEC, that means this triangle. That's why we have joined this line DC. And next we have triangle DBE. DBE, this is what we have, triangle DBE, right? Now understand this. We have learned that between two parallel lines, the area of triangles are same. This theorem we have learned previously in our class 9, that if two triangles are between the same parallel lines, then their area should be equal. Since DE parallel BC, so triangle DEC and triangle DBE are between the same parallel line DE and BC. So therefore what? Therefore their areas should be equal, right? So these two cut down. Why? You write, since area of triangle DEC equals area of triangle DBE. Clear? Cut down. So what do we have here? 1, right? So AE by EC here, denominator, if it goes there, it will be 1 into AE by EC. That means what? AE by EC. And in the right hand side we have what? This numerator whole. So AD by DB, right? So that is what we have was was needed to prove. AD by DB is equal to AE by ECC. AD by DB is equal to AE by AC. This concludes our proof. So let us quickly recall whatever we have learned. So what we have basically done is we have drawn perpendicular DM and EN, and then we have joined BE and DC. Why? Because we needed these two triangles. That's why. Next thing is we have to understand what we need to prove. Now AD by DB. So now you see in which two triangles the AD and DB are there. Then you will easily understand that that AD belongs to triangle ADE and BD belongs to triangle BDE. So these two triangles we have taken, right? So area of ADE by area of DB. The very easy. Area means what? Half into base into height. So triangle ADE's area will be half into base means AD, and height means NE written. Similarly, triangle BD's area will be half into base, that means BD, into height. Height will be same. Height means what? The distance between vertex and the base, right? Perpendicular distance between. So here BD is the same line, right? So perpendicular distance will be same, therefore NE. So here half up cuts down, NE cuts down, so we have AD by DB. Similarly, the same process we have followed for triangle ADE and triangle DEC, right? And then we have done is, what we have done is we have divided 1 by 2. Clear? So when we divide, we get whatever you can see here, and ADE cuts down. And next thing you needed to understand was the because of one theorem from class 9, we learned that if two triangles are between same base and same parallels, then their areas should be equal. So see, this triangle BDE and triangle DEC are between same base DE and same parallel DE and BC. So we should have what? We should have triangle BDE's area and triangle DEC's area should be equal. That is what we have written. Since area of triangle DEC and area of triangle BDE are equal, so they cut down. So now we have AE by EC. This goes there. So we have AE by EC is equal to AD by DB. Okay. And this concludes your proof. Very easy, this one. Though a little bit is there for you to understood. I hope it is clear to you. Okay. Since this is your first class after vacation, therefore I'm going slow. Fine. Next day onwards, we are going to take pace. Okay. Okay. Fine. Thank you. Have a very nice day. This is Srikant Roy signing out.